We've a fairly classic 6-mark bonding question here. We've got three substances: ammonia, iron, sodium bromide. We've got information about melting points and electrical conductivity in the solid and the liquid state. We need to explain in terms of their bonding and structure why the substances listed have different melting points and conductivities. So we just need to take them one at a time. So ammonia first, we need to then explain about melting points and electrical conductivity, then iron, and then sodium bromide. And we have to do all of these. All the information is on our bonding summary sheet, but we'll quickly recap it here. So ammonia first. Ammonia has a low melting point and poor electrical conductivity. That tells us it's simple molecular. So we do need to state the type of bonding for all of them. Melting point first, I'm just going to use the abbreviation MP. That's low because of weak forces of attraction. Weak forces of attraction between molecules. Do not say weak bonds. Okay, the covalent bonds are strong. What's weak are the forces of attraction between the molecules. Because we're weak forces of attraction between the molecules, only a little energy is needed to separate them. Okay, so it's a poor conductor as well. Why is it a poor conductor? Well, to be a good conductor, you need charged particles that can move, and there's no charged particles. There's no delocalized electrons. All the electrons are used in bonding, and there's no ions. And no ions. Why is no ions? Because it's a molecule. Ions are for ionic substances. Iron is an example of metallic bonding. So we'll write metallic here. We can tell it's metallic because the melting points are high and they're good conductors in the liquid and solid states. So melting point first. So MP, high. Melting points are high because the metallic structure has strong forces of attraction. There's strong forces of attraction. Now the metallic structure has regular cations, regular positive ions. Strong force of attraction between positive metal ions. And metal ions are positive because they've given off electrons, and those electrons are delocalized, and they sit around these regular arrangement of metal ions. Between metal ions and electrons, delocalized electrons. I'll put delocalized in brackets there. And electrons. So it takes a lot of energy to separate the ions and electrons, so hence it has a high melting point. Metals conduct because they have delocalized electrons. Delocalized electrons are of course negatively charged, and those delocalized electrons are free to move, which are free to move. Okay, finally, sodium bromide. Let's move this down a little bit. Sodium bromide. Sodium is a metal, bromine is a non-metal. Sodium bromide is ionic. Ionic substances have high melting points because there are strong forces of attraction between positive and negative. I'm just going to use the abbreviation plus and minus because I'm getting a bit short on space. Positive and negative ions in the ionic lattice. It requires a lot of energy to separate them. And finally, electrical conductivity. In ionic substances, they're poor in the solid state and good in the liquid state. Poor electrical conductivity in the solid state, and the reason is because the ions, the positive sodium ions and the negative bromide ions, cannot move. They're held in that solid ionic lattice. Good conductivity when molten, because the charged ions, the ions, can move. Right, and that is an exceptionally standard 6-mark bonding question. You just have to learn the bonding summary for melting point and electrical conductivity for simple molecular, simple covalent substances, giant covalent substances, carbon and graphite, ionic substances and metallic substances, and it will get tested. All these questions on ayleshamhighchemistry.com.